Children, the next topic is tangents and normals. We are studying application of derivatives. The first application was we can use derivative for finding the rate of change of quantities. The second one is we can use derivative for finding whether the given function is increasing or decreasing. Now the next section is tangents and normals. So last year we have studied equation of straight line, slope of a line. So what is the meaning of slope of a line? Slope of a line is denoted as m. If theta is the angle of inclination of a line, what do you mean by angle of inclination? The angle made by the line with the positive direction of x-axis and measured anti-clockwise direction. So if theta is the angle of inclination, slope we can calculate as tan theta. Or the other method is if a line passing through 2 points x1, y1 and x2, y2, then slope of the line is y2 minus y1 by x2 minus x1. Then if two lines are parallel, their slopes are equal. So we can denote as m1 and m2 if m1 and m2 are the slopes of two lines. If two lines are perpendicular, then product of their slopes m1 into m2 is equal to minus 1. Then slope of x-axis. Slope of x-axis. What is slope of x-axis? Here angle theta is equal to 0. So tan theta means tan 0. So slope is equal to 0. So slope of x-axis is 0. Then if a line is parallel to x-axis, there also this line slope also 0. So if a line parallel to x-axis, then its slope is 0. Slope of y-axis, that is 90 degree, theta is 90. So slope is not defined. Similarly, if a line parallel to y-axis, then its slope also not defined. Then we have studied how to write equation of a line passing through a point x0, y0 and having slope m. You remember how to write the equation. Equation of the line passing through x0, y0 is y minus y0 is equal to slope of the line m into x minus x. So this year also we have to use all these. So you write everything in your notebook. Equation of a straight line passing through the point x0, y0 and having slope m is y minus y0 is equal to m into x minus x0. Then if a line passing through 2 points, then slope of the line m is equal to y2 minus y1 by x2 minus x1. If theta be the angle of inclination of a line, then slope of the line is equal to tan theta. Then if two lines are parallel, their slopes are equal. If two lines are perpendicular, then the product of their slopes is equal to minus 1. Slope of x-axis equal to 0. Since what is the reason? Theta equal to 0, that is why. Slope of y-axis is not defined since theta is equal to pi by 2. Slope of a line parallel to x-axis is 0. Slope of a line parallel to y-axis is not defined. Now this year what we have to learn? That is, we have to learn the equation of a tangent and normal to a curve at a point. That is, suppose let this be the curve y is equal to f of x. Then let this point be x0, y0. Let a tangent through this point. What do you mean by tangent? Tangent is a line passing through a point. So for this curve we can draw so many tangents. Let this be one tangent. It passes through the point x0, y0. Then where we use the derivative dy by dx. Dy by dx means change in y by change in x. Like slope of a line passing through 2 points, it is y2 minus y1 by x2 minus x1. So slope this dy by dx at x0, y0, that gives slope of this tangent to this curve at this x0, y0. Slope means it is a number. So, curve equation y is equal to f of x. If we find the derivative, you will get an expression only, not a number. So, the tangent means it passes through a point. That point you have to substitute. So, you will get a number. That means that is the slope of the tangent. So, slope of the tangent dy by dx at x0, y0 means that is the slope of the tangent to this curve at x0, y0. Then how to write the equation? This line passes through x0, y0 and this is the slope of this tangent line. So, we can write equation of the tangent. Equation of the tangent as equation of the tangent passing through. Passing through which point? Passing through x0, y0. The tangent line is passing through x0, y0 and having slope. Slope is the derivative dy by dx at the point you have to substitute x0, y0 is given by, how to write the equation of the tangent is given by, equation of a straight line we can write this format y minus y0 equal to m into x minus x0. So, the point is x0, y0, y minus y0 equal to, instead of m you have to write the slope. Slope is dy by dx at x0, y0, then x minus x0. So, this is the equation of the tangent to the curve at x0, y0. Once again, one curve is given y is equal to f of x and through the point x0, y0 one tangent passes through. We have to write the equation of the tangent. So, for that we need slope. Slope, how we get? Slope means dy by dx at x0, y0. That gives slope of the tangent to the curve at the point x0, y0. This point you have to substitute, that is very, very important. Then, so this gives the slope of this tangent line. Then we can write the equation as y minus y0 equal to slope into x minus x0. Then tangent and normal. Normal means it's a perpendicular line. Let this be the normal. Normal and tangent are always perpendicular. So, dy by dx at x0, y0 is the slope of the tangent. So, how we write slope of the normal? Slope of the normal. Since normal and tangent are perpendicular to each other, product of their slopes that we have studied last year, m1, m2 is minus 1. So, slope of the normal is minus 1 by slope of the tangent. Slope of the tangent, that is minus 1 by dy by dx at x0, y0. So, this is slope of the normal. So, can we write equation of the normal? This normal also, look at the figure. The normal also passing through the point x0, y0. So, we can write equation of the normal. Equation of the normal through which point? Passing through x0, y0 is given by y minus y0 is equal to, slope of the normal is minus 1 by dy by dx at x0, y0 into x minus x0. So, using derivatives we can find the equation of tangent and normal. Then, if the tangent is parallel to x-axis, when a line parallel to x-axis means its slope is equal to 0. So, if tangent is parallel to x-axis, slope is equal to 0. that is dy by dx at that point x0, y0 equal to 0. Then how we write the equation? Therefore, equation of the tangent y minus y0, right hand side is 0, which implies y is equal to y0. So, if the tangent is parallel to x-axis, the equation reduces to y is equal to y0, equation of tangent. Now, what about parallel to y-axis? So, if tangent is parallel to y-axis, y-axis means tan 90. Tan 90 is not defined. That is infinity. Slope is equal to infinity. That is the meaning. Here slope is equal to 0. M is equal to 0. So m equal to infinity means y minus y0 is equal to infinity into x minus x0. Or this infinity we can write as y minus y0 is equal to 1 by 0 of x minus x0. Then cross multiply. So this left hand side is 0. So we can write x is equal to x. So you have to remember these two. When the tangent line is parallel to x-axis, equation of the tangent line becomes y is equal to y0. And if the tangent is parallel to y-axis, the equation of the tangent becomes x is equal to x0. So here give figure that this is the curve y is equal to x square. Then what is the derivative of y equal to x square? With respect to x, dy by dx is equal to 2x. That is the derivative. Suppose this line, okay, what is the slope of this line? That slope of this line is passing through 0, 0. If it is not x-axis, it is actually x-axis, it passes through 0, 0. So dy by dx at 0, 0, that's equal to 2 into 0 equal to 0. So slope of the line, slope of this line, slope of x-axis, that's equal to 0. Then what is the equation of this line? Y minus y0, that is the format. Y0 means 0, slope is equal to 0, x minus 0. So this part is 0, y is equal to 0. Is y equal to 0 is the equation of x-axis? Correct. So this is the method. So here you have to draw the figure. Draw one curve y is equal to f of x. Mark a point x0, y0. Through that point draw one tangent and normal. Then write equation of the tangent at x0, y0 to the curve. Y is equal to f of x is y minus y0 is equal to, another way is here dy by dx at x equal to x0, that is one method to write. The other method is if y is equal to f of x, you can write f dash. Notation is for derivative, it is f dash x0. That way also you can represent. So either use f dash or dy by dx. So this is equation of tangent. So here you have to write slope of the tangent. Slope of the tangent to the curve y is equal to f of x at x0, y0 is dy by dx at x0, y0 or f dash x0. First you write this, then you have to write equation. Then slope of the normal. Slope of the normal is equal to minus 1 by dy by dx at x0, y0 or f dash minus 1 by f dash x. Then write the equation of the normal. Both the way you can write. Then if tangent line is parallel to x-axis, then equation of the tangent is y is equal to y0. If tangent line is perpendicular to y-axis, then equation of the tangent becomes x is equal to x. So you have to, in this section you have to learn only this much. What is the equation of a tangent? What is the equation of normal? Then slope of the tangent, how we get slope of the tangent, how we get slope of the normal, what is the relation between tangent and normal, parallel to x-axis, parallel to y-axis. This much you have to learn.